Welcome back to our evening session. We're going to have a panel of book authors up here. You're going to be able to ask them essentially any question that your heart desires. They may not choose to answer all of those questions though, so try and ask them good questions. Brief procedural point, when you guys are asking questions, please stand up and line up at the microphone because no offense to this particular panel, but all of the other panels that I have dealt with get a bit unruly about repeating questions. And so I think it's better if you just ask the question at the microphone. That way we'll have it on the recording, everyone will be able to hear you, and we can move right along. And to start things off, I'd like to kind of go through all of the authors that we have up here, let them introduce themselves, tell you a little bit about the books that they've written, and hopefully tell you all a little bit about what kind of questions you should be preparing to ask them. And just a note, you do have to turn on the wireless microphones if you haven't yet. All right, so who wants to go first? John, you're holding a mic.
I guess I'm going first.
Go first.
All right, my name's John Lakos, and quite a long time ago, it was 1996, I wrote a book called Large Scale C++ Software Design, and thank you. And it seems to have been a reasonable success. It was my first book. I'm looking forward to putting out another book soon. I've been saying that for a decade, so it's about time that I actually did it. So that's one of the questions I expect is when is the book coming out? So that's all right. I work at Bloomberg, and we have applied many of the concepts that are in the book assiduously. And then there are new concepts that have emerged since then, and that's what the next book is about. It's an extension of the first one that includes many logical design issues that really weren't at all discussed in the book. And then the third part, which is testing, which was completely absent from the book, although the idea of the book was to write code that was testable. The actual act of testing was omitted. So I guess questions you could ask me, I'm going to try my best to answer anything, but you could ask me what software development is like at Bloomberg, because I know something about that. I work in the infrastructure group, and I have a small team that I manage, but there's also a much larger group of people that I influence heavily and teach them and train them to do the kind of software I'd like to see everyone doing. And we have this open source distribution that you can look at, and I think that's probably a good start. All right.
Pass the microphone on down.
All right.
I'm Scott Meyers, and inspired by John's book in 1996, I wrote a book 5 years before that called Effective C++, which has kept me busy in one form or another since then. And just last week, I finished what I hope is the final version of the new book called Effective Modern C++, which is guidelines on how to use C++ 11 and C++ 14. So you can ask me any questions about how John likes working at Bloomberg.
My name is Herb Sutter. I've written 4 C++ books, one of them with Andrei Alexandrescu. The most important one, I think, is the one with Andrei, is C++ coding standards. I think that's one that needs to be updated. I think it's correct as written, but it could use a revision, but it's probably going to be the last of the major books to be updated because we're learning many of these things. But the book that I learned C++ from after my first book, written by some guy who I can't even remember anymore. It was not Bjarne, it was some other book. I made a mistake then. But that I credit with bringing me to where I am today in terms of being interested in C++ was his Effective C++. How many of you learned C++ from Effective C++?
My name is Gregory. My first book, I haven't thought about this for a long time, but it reminded me of it. It was the timeless classic, Using Usenet Newsgroups. The plot was unbeatable, really. After that, I got smart, and all my books since then have got C++ in the title. And back in about 2003 or so, I thought, okay, I'm good. I'm done. I did that. I did the book thing. I took a 10-year break, and then somebody asked me if I would write a particular book, and so I did. And now I think I'm inoculated again for a little while.
Hi, my name is Allain. I wrote the book Jumping into C++, which is targeted at basically new programmers, which is probably slightly different from most people up here. So I am happy to talk about writing. I'm a one-time author, and I had kind of an unusual strategy for writing the book. I wrote it in 10 minutes a day for a very long time. So I'd be happy to talk about any of that process. Talk about life at Dropbox, where I work, and we use C++ for cross-platform mobile development. And that's probably the things I'm most useful to tell you about that these guys won't be better at answering.
Okay, I'm Peter Sommerlad. I co-authored 2 books, where the first one, I believe, has copyright 96, so it was done 95, called Pattern-Oriented Software Architecture, the System of Patterns. I wonder, who has ever heard the abbreviation POSA? Okay, all the others, go out there and check out. The book is still on sale, and it's valuable. It tells something about software architecture and design. And it's still well-cited, and people work with that even after almost 20 years. Another book, the other book I co-authored is called Security Patterns. I deliberately brought a copy. It's not as popular, but also if you're in the security domain and aren't a security expert, but a software engineer, it can help you to speak their language and get the gist of some of the concepts. And there are some of my co-authors there continue to work on that, and also valuable stuff to learn. At least the POSA book has C++ examples in them, but it's old C++, so don't take them literally today. I also have a half-written C++ textbook on my computer that I have no idea when I will be able to finish that. I would need another sabbatical, but if you're interested in how I teach C++ to programmers who know Java, give me a call, send me an email. I'm happy to share that with you.
So my name's Aid Miller. I've written 3 books now, one on .NET, one on parallel programming with C++, and a book on C++ AMP with Kate Gregory. Yes, this Kate Gregory. You can ask me pretty much anything you want about authoring. I wrote all the sample code for all my books. I have some pretty strong opinions about that. You can ask me my favorite writer's retreat story if you want to. That'll probably be amusing.
I have one question. Why is Bjarne not up here? Come on. Come on up.
Bjarne,
Please.
come on up. There we go. There we go.
Sorry.
Hi, I'm Herb Sutter, and
Keep going, Michael.
All right.
I'm Bjarne. Had a very good dinner. Came in a bit late. I'd hoped to escape, but didn't seem to work.
So my name is Michael Wong. I wrote a book many of you probably haven't heard of. It's a C++ 11 book, but it's actually written in Chinese. Now, let me just a little bit, just to give you a little bit of background here. I joined the committee about 10, 11 years ago. I can't remember now, I'm so old. But I started by reading every book by every one of the people around me to get myself acquainted with what needs to do. So this is not necessarily the price of entry, but it was a very good education for me. So I'm absolutely ecstatic to be sitting among this group of people now, 10 years later. So you can ask me about anything about C++, about OpenMP. I'm working right now on the next book, which is not about C++. It's about OpenMP. You can ask me about what it's like to write a book in a language that I don't understand, and what it's like to review a book in a language that I still don't understand. I'm in fact going to China next month to do a book tour in a language also that I don't understand. So let's see how that goes.
All right. Bjarne, I didn't catch it. Which books are it that you've authored, and how many of them?
I've got 3 current ones. I mean, there's the C++ programming language, which is everything about C++ in 1,300 pages, just like the standard, except not written in standardese. I'm told that the English is acceptable as opposed to standardese. And then I have programming principles and practice, which is actually for people who don't know how to program. and you can learn it from scratch, from knowing not a line of code. I've taught thousands of novices using that, and the last thing I did before officially leaving academia was to upgrade it to C++ 11 and a little bit of C++ 14. And then the one I'm really proud of is the tour of C++, which is everything about C++, language and library, in 180 pages. And that had been conjectured widely, including by me, that it couldn't be done. And so what I recommend you to do, those of you who has a plane journey home, get a copy and get everything about C++ on the flight back.
Thank you. And just so you know, there is a whole table of books right outside. So if you do want any of these books, you can pick them up, and they will even ship them home for you in case you happen to pick up a few too many to take on the plane ride home.
What is the most important C++ book?
So Herb, you realize that it's supposed to be a panel for them to ask you questions.
But I'm
You're supposed to be answering questions.
I thought it was about asking questions, so I'm asking the panelists. I actually want to offer an answer. I actually don't believe it's the C++ programming language, although that is extremely important. I actually don't believe it's effective modern C++, although that is equally extremely important. I think it's a tour of C++. And the most important thing you need to know about that book is, for the first time in a long time, we have a single answer to people who ask the question, what book should I read to learn C++, to understand what C++ is about? We have not had a single answer to point them to. That we have a 180-page book that does a good job of that. That should be the first book everyone should recommend, and that is an important role for many people who are learning C++. So I think it's really important, even though it shouldn't be the only book you have, but it's so important to know to recommend it.
Absolutely.
You don't think people should start off with one of these things on universal references?
Yeah. So okay, so the way this is going to work, just so you guys know, is I want everyone to line up at the microphones, and you can go ahead and start lining up now with your questions. That was not actually just a polite hint. You better line up at the microphones with some questions. The only thing I will warn you about is that I'm going to be completely ruthless to the people in the audience asking questions, because I want to make sure we get a lot of questions asked. And so if you have a long question, you got to make it nice and short. I will try to be ruthless to the guys up on the stage, because I want to get a lot of questions asked, but you outnumber me. And you have the stage, and so I don't know that I'm going to win that one, but I'm going to try. All right, so we have our first question from the audience.
Yeah, so this is for everybody. It's like, when you guys are doing your writing process, we all have to write design specs and all kinds of stuff, and it takes forever. You get brain locked. So I've noticed when I try to do it, when I get brain locked, I send myself emails or I explain to somebody else, just to keep it in the flow, so you can kind of get content out. And I was just really, really curious of all the techniques you guys use independently to get yourself free from a block and just get into that flow mode, because that is, I think, so important, and I'd love to learn from you guys how you do it.
I learned to do something counterintuitive, and I learned it writing books, and I now do it when I'm doing code. Is I never stop at a sensible stopping point. So when you finish something, you're like, oh, I finished this chapter, I can go to bed because it's far too late. I never do that. I start the next thing. And maybe I only write one sentence, or maybe I write 3 bullet points or something, doesn't matter. And then I stop. And I now do the same thing with code, where I'll write the function that I'm going to write next, but I won't actually fill anything in, and I go away. If you stop at a stopping point, then when you go to start up again next time, you have this huge ramp up. And if you just stop right in the middle, oh, it's 11 p.m., I'm going to stop right now, it's actually easier to start back up again the next day. You did 10 minutes a day. How did you do that?
Yeah, so I think it accidentally did exactly what you described. So I would literally work for 10 minutes. Actually, I'd look at the clock and it'd be like 10, and I'd be like, I'll work until 10:11, because I didn't really know exactly where the 10-minute boundary was. And I just forced myself to do it every single day for 2 years. And so I basically never stopped at a logical stopping point. I'm not even sure that I could it would have been virtually impossible to find those stopping points in 10 minutes anyway. And then the other thing I did was I always forced myself, like, you can always do something for 10 minutes, right? Like, there is no way you can't come up with something useful that will fill that time. And so even if I didn't know what I wanted to say next in like a particular part of the book, I'd go do something else that was useful to getting it done. Because a book has a lot of things. You have to make sure it sounds good, it flows together, that you're covering all the right topics. There's like an infinite number of things that are kind of important. So I would just find one that I felt like that particular day I was interested in doing. This is not going to help you at all writing a spec because it's a slightly different time horizon, but it can be a really good way of like making progress because you just sort of force yourself to keep going, and you always kind of have it like in like maybe L3 cache or something where you're like, yeah, I can kind of remember what I was doing yesterday well enough to keep going, which really helps. And write it down. Whoops. Write it down is my other tip. Like I would just had a spreadsheet and like it's like 500 lines long, and every day I was just like, this is how many minutes I worked on this, and they were all 11.
Anyone else want to?
So I struggle with writing, but I really like writing code. And to me, a technical book is really about explaining your sample code, right? If your sample code is atrocious, then your book is going to be harder to write because you've still got to explain it. So typically what I do is I go back and I work on the next bit of code because I'm trying to make sure I have the samples for chapter 2 while I'm writing chapter 1. So I can go and do something more useful that I like more than trying to figure out how to explain a particular piece.
Good choices. For me, it's basically work consistently once a week, 1 hour, say on Tuesday morning. That's when I can do it, and then just keep going every for the next 3 to 6 months. But if I'm stuck, I don't know. I talk to people. I've got great resources around here. Sometimes they jog me loose, and then I can start going again. And sometimes it's just as simple as that. Work with your colleagues.
I think I did better the first time than the second time for sure. First time I started was around 1993, and it took me about 14 months to finish the entire thing. I was quite proud of myself. I worked constantly, late into the night, and then it took another almost 2 years to get it done after it was done. And I still work constantly, but I was becoming a little bit more, setting my standards a little higher and wanting to make sure that everything was just so. Unfortunately, the next round, I decided to take on a much bigger thing, and I worked every day, but after about 10 years, it gets old. So it's really hard to say, yep, I'm gonna put in another however much time, because after 10 years, it's just really hard to say, yeah, I'm gonna do that and do that. Now, the good news is, over the course of that time, I've been giving a lot of talks, I've created a lot of presentations, I've gotten a tremendous amount of feedback. The downside is that I learn more, and there's this unfortunate thing is you have to make progress on the book relative to how much you know. Otherwise, you wind up rewriting it and rewriting it and rewriting it and never getting it up. But the good news, I'm much better at delivering talks than I am at books. So I have a lot of experience with that. And I think that's good news, because now at least, even though the book it's really getting there, but at least I have all the material and it's been vetted and I know it works. So there's some goodness to that.
If I may add something to that, both POSA and the Security Bandits book was a collaborative effort. And two things I have to say. One thing is, don't be afraid to rewrite stuff. POSA 1 was written at least 4 times. So don't be afraid of that. If you really care about quality and not want to become rich as an author. The second thing is, if you collaborate with others and you share a common goal, it's much easier to get forward, even though you have to write things 4 times. And all the other good things I take home with me to try to ever find the time to finish my C++ book.
When I read a book, I really feel that if I can hear the author's voice ringing in my head, complete with weird accents and peculiarities of their speaking patterns, then I feel that something has succeeded. If it feels like dry academic text, somebody has written yet another dry academic text. And so giving talks about the subject really helps. And for many people, including people on the stage here, I can hear them when I read it, and that's good. The other thing I have found is I cannot write in a day. That's about as long as it takes to fill up the cache. On the second day, after having a really awful day, on the second day it comes out. But that may have to do with the fact that I'm writing things that sort of are very large and has to be complete. It's much easier to write short chapters and short sections.
All right, let's see if we can get another question. We'll switch mics.
I had a question. It's for anyone who cares to answer. And it's basically C++ is one of the few languages that still has header files. I was wondering if that's something that we're ever looking at changing, or there's definitely that need for a declaration versus a definition. And I don't know if that's like so woven into C++ that never changes, or if at some point we get to a point where the compiler is generating the headers for us.
I think our moderator should answer that question.
Header files must die, to paraphrase Andre, but I think Peter would write it.
Yeah, in the meantime, you can try our Eclipse CDT or Develop IDE, where you can actually, at least if you want to change a signature, toggle the definition into the header, change it in one place, and toggle things back so you don't have to edit two files. That's a workaround until Chandler gets done.
No, not me. I'm doing none of the work here. Anyone else want to try and answer that question who's actually in the panel? Because I don't feel like I can really.
Herb?
Herb, maybe.
We have voted you to answer the question.
Okay, well, again, I'm not doing any of the actual work on it, but I'm talking with people who are, like, especially the Chandler's team and Gabby at Microsoft, Gabby Dos Reis, who's also here at the conference somewhere. Modules are needed for two main things. There are more.
What are modules?
Sorry. We need modules. Modules are needed for two main things. So when people hear the word modules, they often think libraries or DLLs or shared library. That's not what we mean when we say modules. We mean build time, source organization, build organization. The two main problems are build scalability. If I include the same header in 100 translation units, why on earth do I have to compile it 100 times? And second, macro isolation. Because when I compile it 100 times, will I get 98% of the time the same macros? And what does that do to ODR violations, et cetera? So there is more to it, but especially build scalability to go number of headers plus number of source files instead of number of headers times number of source files, and macro isolation. Those are two specific problems that should be solved.
Macros should die.
Macros will die. Everybody says macros should die, and I agree with them, and that will not happen until somebody comes up with a replacement.
Macros don't want to die. I've been trying to kill them for at least 20 or 30 years because they actually serve a purpose. And like everything else that doesn't work in C and C++, you can't just ban it and make sure it doesn't disappear. We have two ways of going forward. One is to find a better alternative. And two, I'm hoping for static analysis and code transformation to actually transform the old crud into the new stuff. And I think that's where the future is. And by the way, I don't think it's the header files that's the problem. Having the declarations, the interfaces specified in a separate place is good. Having two things, the declaration and the definition, is good. And it is, as Herb says, a really bad thing if you have to process that header file, that interface specification, 100 or 1,000 times.
Awesome. Moving right along to our next question.
Hey guys. So one of the most fulfilling things I do is teach my 11-year-old programming. It's a lot of fun. And I've been using this book. It's called Hello World by Manning. It's how to teach kids programming, and it's in Python. And it's been working really well. And my question to you is, do you think there's a world where we'll actually have a beginner book in C++ we can teach children? I mean, because that's the programming language I grew up on. But I would love for my son to deal with real bits and bytes and machine and memory instead of having all that sort of abstracted away by Python.
My take on that is C++ is a professional tool, like, let's say, a chainsaw for cutting a tree. Would you give an 11-year-old a chainsaw?
This 11-year-old took Herbert Schilt's books back in the day and read them. So.
Well, at going native.
That was bad.
Anyway, at Going Native last year, we had on stage some people who happened to mention in passing that they learned C++ when they were 10. Certainly doable. Bjarne's got a book on learning programming starting with C++. But the language isn't the important thing. The only mistake you can make is to teach people one language, whether it be Java or C++ or anything, and say we're done, and especially give them a degree. That should be a crime somehow, at least it shouldn't be called computer science or computer engineering, software engineering. But for a kid, I learned BASIC, and I wouldn't have it any other way. Atari BASIC of all things, my goodness, it could have just as well been Apple BASIC or something. The most important thing you can do for a kid who might be interested in interacting with machines in a sensible way is to help them to interact with it, to be able to write a program that makes them respond. Just echoing my name, we were talking about this at dinner, is so important because I can make it do something and it responds to me. If you get that hook into them, that 2 lines, they won't stop. And they'll go on from there. The language you start in is much less important.
Agreed.
All right.
I was inspired by the question about modules. There is another problem, in my opinion, about the language that I actually wrote a proposal on the forums a long time ago, which is sync arguments. Basically, there are occasions where you need to pass arguments to functions or constructors that basically get copied or moved depending on whether it is an L value or a value. But because of the signature of the function or of the constructor, there is an additional copy or move that can be avoided by creating additional overloads that take R values or const L values. The problem is that when you have a single parameter that you have to pass to the function, it's very easy to create the overloads. But when you have multiple parameters, you actually have to create 2 power to the n overloads for the functions. And this is an obvious problem in my opinion, and I wanted to know if there is any kind of work being done about this.
My answer will be on Friday morning.
Okay.
For the specific problem that you have, basically this is what perfect forwarding and universal references was invented for, was to make it possible for you to take any number of parameters, L values or R values, const or not, up to a variadic number of arguments, and then forward them to wherever they want. And because you're passing by reference, you're not making any additional copies. The difficulty that you have is that it generally has to be templatized, so it's going to be a template, and there are certain kinds of entities that cannot be perfect forwarded. Braced initializers, for example, can't be perfect forwarded. Overloaded function names can't be perfect forwarded. Template names can't be perfect forwarded. However, within basically the current language tool for addressing the problem that you have is universal references. Now, you mentioned specifically, for example, doing it with constructors, because it makes sense. You want to take some arguments, you want to pass them to your data members. It turns out that there are some unfortunate interactions between the templates that will be instantiated from a perfect forwarding constructor and the copy constructor and the way the copy constructor gets called, which leads to some really unpleasant programming problems. There are solutions to them. Now, your question was whether there's any work being done on making things better than that, and other people here would be in a better position than I to answer that question. But what I will say is the particular problem you're facing does have a tool that can address it. There are some side effects which are not necessarily pleasant, but they can be dealt with as well. And if I may be permitted, I have 2 items in the new book specifically focusing on that. So buy 100 copies.
Tonight.
I think if this is your biggest problem, you should be very, very happy.
Thank you.
I have not done it, but it sounds like writing a book is a significant investment, time and blood, sweat, and tears. And your subjects in your books range from very general language survey to domain specific. How do you find what to write about? And how do you choose to dedicate X amount of your life to pouring, that much effort into something that people will learn from?
I'll start with this, claiming priority for having written the first book on the subject. I know how it started with me. I was standing in the doorway of Allain, who you may have heard about. He wrote the Dragon Book and such. And I was belly aching about the users who kept asking the same questions over and over again, and it was interfering with my work. He looked there up at me and said, "Bjarne, you have to write a book." And I said, "What?" He said, "Yeah, if you write a book, you can put down the answers in the book, and then you can get on with your work." He was seriously wrong, because that just means that more people could ask harder questions.
My advice to people who are interested in the possibility of writing a book is it's a giant amount of work. Really, it's a giant amount of work. For me personally, I find that it really helps to have a very strong desire that you have a story that you want to tell. You have some information that, for whatever reason, you just want to get it out of you. You think either it will be useful to people or cathartic for yourself or something. Because then you're sort of doing yourself a favor. It doesn't change the fact that it's a lot of work. But it helps a lot if you can say, my primary motivation here is I think that I have a message that is important to get out for some reason. And if you have that internal kind of motivation, then the blocks that you may have and the research problems you may run into and the giant amounts of time it's going to take, it's all worthwhile because you realize I'm accomplishing something which is important to me. So my recommendation is that if you're even toying with the idea of undertaking a big project like this, make sure that there's some internal motivation that will carry you through the difficult work, because it is intensely satisfying when it's done.
Yeah, I wouldn't be looking for a subject to write about so much as finding a subject that finds you, that you feel compelled to write about. I got into GPU programming quite a long while ago and was just blown away by, it was the first time I used a computer in a long time where I actually couldn't believe how fast it was. I thought my code had no-opted somewhere. It hadn't done any calculations. It couldn't possibly have done that in the amount of time I gave it. And it had. And I played around with CUDA, and then I got in touch with the C++ AMP guys, and I was just really motivated to write a book about something that I really cared about. I think I would never go and sort of pick a subject that I wasn't really, really passionate about, because on the 11th consecutive Sunday night, you will be unhappy.
And I think that what Bjarne and Scott and Aid and others have said, write what you know. Be passionate about telling something. That's how I started with Guru of the Week. So I just, hey, I wrote it because I wanted to share with the people in my office, and then on Usenet, remember that. Kate knows about that. I liked your book. Here's something cool I learned, to share it. So that's one important thing. The other thing too, and so write what you know. You'll often hear about it from people who teach about writing. The other one is, this may sound contradictory. It's okay to have a goal to write a book. That's a perfectly fine goal. But the most important thing, if you just want to be a writer, the most important thing to do is write. You don't need to set out to write a book. Just write. Write frequently. Write a little bit in one day, more another day, but write. And you may edit away 70% of it. And it will hurt at first. And then you'll realize it's better, and you realize it's part of the process. But just write. And that will go a long way. One thing that works well for some books, it worked well for Scott's book and for mine, and I fortunately started with small items, is you can focus on one thing, ship it. And then the next cool thing I learned, and they didn't even have to relate to each other, because I could just make a book of, oh, here was just the first 50 I happened to write. So I didn't have to actually plan a book, which was kind of nice. Scott actually did short items and planned them, which was more work. And then in your second book discovered that short items was a feature. So that's actually a learning. So there's benefits to doing that. But no matter which way you come at it, whether you start to write a textbook so people don't ask you questions, or the same ones, ask you new ones at least, or something else, just write.
I would echo that. For me, I started by writing a website and writing tutorials and kind of exploring over time the challenges of explaining C++ to people. And then I got really unhappy because as I learned more, I was like, wow, this isn't really I don't like what I wrote that much, and I want to do better. And eventually, so first of all, if you don't actually want to write, you'll find out that you don't really want to keep going with that, which is great. And you don't feel like I have this half-finished book somewhere that I'm never going to do anything with. You have instead this stuff on the internet that everybody can read, and hopefully they think it's okay at least. But then you look at it and you're like, wait, you might come out of it thinking, oh, there's actually a narrative structure I have in my head. And the reason I wanted to write a book was because I was unhappy with the lack of sort of this coherent narrative structure, because people randomly find a particular thing on the internet, right? I wanted to be well, you're going to start here and you're going to finish here, and in the meantime, I will have a logical path for you that hopefully will actually teach you things in a particular way that builds on top of itself very logically. And so to me, that was eventually that motivating factor that you all were talking about, where it's I want to add this narrative structure. So I would say first explore your desire to write at all, and first explore the space with sort of these little disconnected units. And then if you see something that ties them together in a way that you think is interesting, go for it.
We all know that the last 10% of a project takes 90% of the time, and that this rule applies recursively. This is also true for writing a book. And so it gets really, really painful towards the end. Satisfying after you've shipped it, yes, and scary. I don't dare open my book for the first month after it comes back from the printer, because I know I'll find something I screwed up. So if you want to write, think why you want to write. If you want to be rich, pick a different field. If you want to be famous, maybe, and there's probably quicker ways of doing it. If you have something that you really can communicate, and you have some ideas of how to get in under the skull of some readers and do something good for them, go ahead, all the best for you. But for the rich bit, Ravi Sethi, who wrote the teddy bear books on programming languages, came into my office one day towards the end of one of his books, where he was sort of rewriting, and says, Bjarne, I have figured out that you get paid better per hour for pumping gas than to write a bestseller. And then he proceeded to do the calculation on my whiteboard.
I think you've hit on a good point there. It's really tough to find a good niche, especially among this crowd, of writing a C++ book. It took a long time for me to figure out something that was reasonably different and interesting. And every time you kind of have to do that. But ultimately, there was something that motivated me. Was when I was really young and I was in school. I remember my guidance counselor taking me to the library and said, maybe one day you will add to this library of books. And that was something extremely memorable to me. And maybe ultimately that's probably what motivated me to want to do something like that. And sort of running with this crowd sort of helps too. So I'm actually working on the next book now, which is on OpenMP, because I see a big niche there in that there's new information coming out, and there are not enough books there. So there, it was a little easier to find a niche. C++, it was difficult.
Can I just say really quick that the tiniest sliver of that has led me to do a 5-minute lightning talk. Wednesday morning, the perils of strict aliasing. But thank you.
So I have a two-part question. First of all, have any of you been tempted to write a book on a different programming language, such as maybe D? And secondly, are there things that C++ could be borrowing from other languages, aside from modules, and stuff we've already borrowed from other languages, such as type inference, that maybe you think we should be adding in C++ 17?
An incendiary question.
Why me?
I'm a huge fan of PHP, actually. I'm thinking of running a book.
Really?
So my mechanism for writing books is someone asked me to, and luckily outside of C++, nobody knows who I am, so I'm never going to have that problem.
So I guess I am trying to write a book in a different language, but it's not that different. I mean, OpenMP is a pragma-based language, and it's based on C, C++, and Fortran. So I don't know. I don't know if my range is wide enough, but there's enough there about parallelism that I can talk about.
Well, since my books are not language specific, I use different languages as well. So that might answer a little bit. And I used to teach different languages from C before I knew that C++ existed, through Java, Pascal, whatever. Just think about it, a lot of languages. And we already said that it's important to learn more than one.
Yeah, and I think everybody on stage can and do write in more than one language. I must say that there's one kind of book that I actually really, really dislike. And that is the kind of teaching book that does X in Y. And then you do X in C and X in X2. And so you get essentially the same book where they vary the syntax for 10 different languages and basically teach what can be expressed in all of those 10 languages without ever showing what is good about any individual language. And that is among the books I dislike the most. I think a book about a language, a big book about a programming technique, a book about an approach to software development has to be written by somebody who's passionate about it. And if there's a language component, it will probably not fit in very many languages.
May I add to that? Many, let's say, programming textbooks are written after the model of Niklaus Wirtz and I believe Kathleen Jensen's Pascal User Manual and Report. That was never intended to be a textbook on programming. It was a compiler handbook. But it sold so many copies because everybody was teaching Pascal, which is now Java, that we learned. And I would say 90% of the programming books are modeled after this compiler textbook, and they, in my opinion, fail to actually convey the message what programming is about. They tell you at the first thing what a comment is and how to spell that without giving you any reason to write a comment. Just an example.
All right.
Is there nothing about any other programming language that anyone admires that we don't have in C++?
Well, let's say functional programming, all kinds of languages in that dimension.
No.
I know you like modules. Someone mentioned modules earlier. That's
Some of us have spent years dodging questions that could lead to language wars.
So to the first one, actually, I guess I'm within a month of having written a book, and I've been that way for about 5 years now. Effective concurrency with examples in C#, Java, and C++. Actually, most of the examples are C++, but because I wrote an effective concurrency column about a book's worth, and I shouldn't say this with my editors in the room, but I just need to I just need to have a month of downtime to assemble it into a book. Having said that, one of the things we considered was, should there be 3 different books, one for each language? Why? The problems are so common among them, so that's the closest I would come. But I actually would push back on many of the examples you gave in your second one, especially because they were characterized as borrowing from other languages. Yes, we should learn from other languages. Modules is not being borrowed from any other language. Many of the other examples were not borrowed from a given language. In fact, the features that are done well learn from other languages, which we should do. Look at lambdas, look at other things. But build them for C++. If you actually borrow another language's feature, it will almost certainly be a poor design. for your language. So, and in fact, it's not just a semantic difference. The change will be so much that many people, especially of the original language, may view it as, well, that's not that feature. No, it's the way we did it, right, for what's right for our language. So you learn, but the direct borrowing I want to push back on. No modules and other things weren't borrowed from other places.
Let me not use the word borrowing then. Learn then.
Inspiration is a good word. Thanks, Kate.
I had a best practices question. My team and I work on GCC 4.3, and it doesn't have much C++11 features available to it. And we've got an ongoing debate on our team about whether or not when you pass non-trivial types to a function, whether you should be passing those as const references or whether you should just pass them as value, by value.
Go to Herb's EndNote talk.
Okay.
Actually, given that you're basically working with the C++ 98 compiler, so the first thing is you're going to be passing them by reference because you don't want to copy them. And if you don't have to do any operations except read from them, then you're probably going to want to pass by reference to const. If you have access to C++11 features, do they have R-value references in GCC 4.3?
No.
Okay, so your choices are restricted. So listen to the first 5 minutes of Herb's talk, and then you can stop.
And of course, the answer for C++11 is passing by value.
And anyway, upgrade first. It's a good idea. You get better tools, you get better compilers, better error messages, better features.
I was kind of hoping that one of you could channel Andre, who couldn't be here, because I think Andre would have enjoyed answering the upgrade side of this question.
If it were at all possible, we would have done that.
I just want to point out that the way that you're going to pass something depends on what you're going to do with it. So if you're just going to be looking at it, you're just going to be reading it, pass it by reference to const, then that's all you have to worry about. That doesn't change in C++11, because all you want to do is look at it. If you want to do more than look at it, like you want to copy it, then it becomes a matter of what is the type, is it a conditional or an unconditional copy, how big is it? It becomes a fairly complicated question. No, the answer becomes fairly complicated, but Herb will be attempting to simplify that with some reasonable guidelines. But that depends on having C++11 features. But what I do want to get across is it's not simply a matter of how do I pass it, because you have to take into account what am I going to do with the parameter once it's been passed in, because that will affect the answer.
And trust the optimizers, maybe not with your ancient compiler.
Okay, thank you.
Hi, so I was wondering, the C++ language is so big, it keeps getting bigger, and like you all mentioned, like before doing anything, you had to read tons of books about C++. Like everybody in this room has had to study it for hours. And it seems like even when you make a simple statement, it's so easy to make a mistake that will get everybody on their back about all these things. And even if you say something that isn't technically wrong, people will still have very strong opinions about what you're saying. And so it makes it very intimidating to actually go and try to teach someone something, because it's so easy to get shot down. So I'm wondering what led you guys to make the transition from being a student to a teacher in confidence?
I was teaching C while I still was a student, and I learned the language so deeply I would never have learned it from teaching than from using. So the best thing to learn something is teach others in using it. I'm not sure if that answers your question.
When I teach freshmen, which I've done over the years for a few thousand students, there's always a point where there's some smart aleck in the audience who knows he's smarter than the professor because you're smarter than all of his high school teachers. And he is busy telling everybody in the course that you shouldn't listen to the professor. He's using these features that are weird and and horrible and, yes, inefficient. You should really use C-style strings and arrays and such, and not the vector kind of stuff. And in any group I find there's always this guy that's trying to intimidate you with his superior knowledge of obscure details that'll probably do you harm if you know them, and will stop you from sleeping at night because you're trying to find bugs in your very complicated code, trying to squeeze the last little cycle out of a piece of student code where you couldn't tell whether you ran 100 times slower anyway. And what I usually did was I waited till I knew who the smart aleck was, and waited till he asked a really stupid question. And then I asked him, efficiency. Yes, efficiency is important. Efficiency is at least sometimes important, especially for experts. Which optimizer level do you use? And the usual answer is, okay, are you using GCC Clang or Microsoft? Okay, yes. Are you using a Mac or a Windows box or a Linux box? Okay, so you didn't set any optimizer settings? No. Are you aware that your highly optimized buggy code is running 10 to 20 times slower than the recommended code if you switched on the optimizer? You always have to find the person who is trying to be overly clever and optimizing where it's not necessary and writing code that is far too complicated. So actually my keynote tomorrow is all about how you can try and simplify. And we just have to push back to people that want you to know every single rule in the standard. I don't want to know every single rule in the standard. It makes me a worse programmer if I remember all of those rules. Yes, I know where to look them up. There's lots of books there, and if everything else fails, you can try the standard. But most of the time, when you get really confused and worried, it's time to simplify your code, not to figure out how to write really complicated code, because quite often you're just defeating the optimizer.
So I guess I'd say two things. When I started doing lots of speaking at conferences and stuff, I was always really worried about that guy with that question. And I don't think it's C++ is really complicated. I think technology is really complicated. And I also think that I don't know, we'll have to think about that, is a completely acceptable answer. Expecting someone to know everything, even if they're an expert in that field, today is just ridiculous. And the second thing is that the best thing about getting old is you kind of stop caring about what other people think.
Well said.
That's really good advice. I wanted to tie back to what Herb said earlier about if you want to write. When you write and other people read it, and someone's that guy and digs a hole in it and tells you that you're wrong because and blah blah, eventually you write something that someone doesn't do that to, and then another thing, and then another thing, and one day you look up and you're confident and you don't care what other people think, and you're not even worried if there's that guy. Most of us still have to worry a little bit about that guy because we can't pull the same creds out of our back pocket that you can pull out of your back pocket. But you do stop caring quite so much, and it doesn't go from 0 to 1, right? It goes from 0.1 to 0.8, and that's good enough.
I think we worry about that guy a lot, and I know I did when I started, but after a while, listen, I get shot down all the time, and you get used to it. And it doesn't bother me much anymore. But the other thing I find is most people, the majority aren't trying to shoot you down. They're actually trying to be helpful. They really are trying to help your talk. If you're stuttering out there because you're a little nervous, they will give you the room and space. I really don't. I've been doing this for 10 years, and I don't know if I'm getting better, but I'm enjoying these a lot more now because I think that the audience is extremely friendly.
The point was not that everybody is out to get you. It is that often in a class of 200 students, there are 10 who are trying to prove their manhood. They're always guys by showing how smart they are. And you have to stop them actually polluting the teaching by complexity. And that was the purpose of the exercise. No, most people want to learn most people want to write the simplest code they can, and certainly in an audience like this, I suspect that is more the case than the audience I was talking about.
I give you a tip. I teach C++ first in a despotic manner. I say, this is how you do it. Even if there are other ways, I tell you how, and that's what you have to put in your exam. And second, I teach them to write C++ without handwritten loops most of the time. So they learn the standard library very well from the beginning. And that's also something that's important. I learned that from accelerated C++, and I try to mimic that style. So get accelerated C++ because my book isn't written yet.
I have a question about what motivated your question. Are you sort of thinking about making a transition from learning about it to teaching other people, or was there some other motivation for the question?
I do have one friend who keeps nagging me. Like I tell him, oh, look at this cool thing I learned about C++, and he says, so when are you writing that book? And I'm just like, well, I can't write a book yet. I have to read more. So I'm running like, where's the point where like you've read enough to be an author and not say stupid things, basically.
Write something.
I've been doing this for close to 30 years. I still write lots of stupid things. No, some of the people on here have been reviewers of my draft book. Trust me, I write stupid things. But you hope to write fewer stupid things. If you feel like you have a story to tell, if you feel like you know some stuff that other people would find useful, and if you're interested in possibly writing it down, give it a shot.
If you don't write stupid things, it's because you've gone stale.
Yeah, I mean, another way to look at it is, whether or not people are criticizing you because they're jerks or because they're right, like both of those are only going to help you get better, and it doesn't really matter what they think. It just matters what you get out of it. So, and worst case, you can always turn off the comments on your blog.
And I think all of those are good advice. Granted, I agree completely with them. Some of them are easier said than done. It is easier to say, well, just let it roll off your back, than to do it when you wake up at 2 in the morning and there's just, for some reason, one comment seared in your mind and it just bothers you and it's going to bother you for a week. That's going to happen no matter how long you've been doing this. Trust me. But there's one thing that I've found that's very useful that I think applies not only to writing, it applies to coding, it applies to software design, it applies to other kind of design, and that is to be egoless. As much as humanly possible. You're not going to be completely egoless. But to be egoless, because if you're egoless, then if somebody gives you a criticism, you can just evaluate the criticism. Is it valid or not? If he's just being a jerk, meh. It's not like, oh, and I'll get mad. It's like, no, oh well, it's his loss. Or, but here's a piece of feedback. Oh, he's right. Cool, thanks, I learned something. That's the spirit that improves designs. I remember one very esteemed person I was doing a design with once a few years ago, and we were whiteboarding something and spent a lot of time on it, and then realized it was completely broken. And he's sitting right here, and he excitedly said, great, we've proved it can't work. This is progress. That's the spirit. And there's a lot of Benjamin Franklin and Thomas Edison and other lines to be said there. But that kind of spirit of wanting to keep learning, and that helps a bit, although we're all going to be human sometimes.
Thank you.
So I was just curious what kinds of tools you use when you're writing a book, because like trying to get consistent code blocks in, say, a WYSIWYG editor is frustrating sometimes.
He's been fighting the good fight.
Okay, so for all of my books except the most recent one, I used FrameMaker. Every time I used FrameMaker, I said, my God, I hate FrameMaker. I will never use that thing ever again. And so when I started a new book, I would do some research to find out what was better, and nothing was better. So the vicious cycle repeated itself. So for the most recent book, I said, okay, I'm really going to make a change this time, so I decided to use Microsoft Word. I said, it can't possibly be worse. I was right. It's not worse. It's just horrible in so many different ways. What I will say is I have not personally spoken to any authors who, when they were done, said they were thrilled with the particular technology they used for writing. Everything's got advantages and got disadvantages. I've written stuff, I've written long documents in LaTeX, I've written long documents in Scribe, I've written long documents in FrameMaker, in Microsoft Word, they all suck. So, but they can all be made to work.
Agreed. And just want to add one thing. It's not the tools that's the main problem.
Sure.
I have maybe add to that. FrameMaker was great. Compared to, let's say, Androff, which I used also. I was deliberately using Androff. Yeah. And today, when I write a book, my not finished C++ book using real code examples, I use LaTeX and include the real code that compiles and runs and tests well to make sure it's real code. And that's the way for me now.
So that's actually a feature with Word, because if you type code into Word, like terrible, awful things will happen, like it'll fix your lowercase I for you and stuff like that. And so as a result, you must paste code into Word from a code editor, and that turns out to be a feature. It doesn't feel like it while you're swearing, but it's actually good discipline for you. You should never, ever type your code where you're typing your words.
When I was young, we used Edelin uphill both ways in deep snowdrifts. But the reason I patted Scott on the shoulders is because I know that in particular, he has led the charge over the past 2 years in particular in struggling with what is the best tool, what is the tool if you want to have, just like a single source targeting multiple platforms, same thing with Word or whatever you're using. How do I write once and then target not just print, because FrameMaker's great for that, and Scott liked to do his own page layout, wonderful. Then you curse at the tools, but it's a good tool for that. Now people want ebooks. They want web. And it turns out all of these tools were developed in silos, and none of them talk to each other. They all have different formats and options and compatibilities, and no one has solved this problem well yet. Scott, you're the one who has done the most heroic work I know of trying to make it work, and it ended up using Word, which is good, okay, and I've done all my books in Word, sorry. But I also know what it does wrong, and the team would only fix running heads. They should be per chapter and per section, never mind. But the problem has become more difficult, not less difficult, because of the proliferation of formats. It's no longer just print. You could go online only. Turns out some people like print, and I like print for some things. And we've actually got more diversity, and that makes it even more of a challenge to find a tool to write with. But find one. Just write. The rest can be worked out by your editor, and you'll find solutions to the other things.
Maybe Markdown.
If you have suggestions on tools that you've written non-trivial technical documents with, let's talk.
One thing I want to mention, our queue is growing rather than shrinking. So I would like to encourage the panel to be as direct as possible.
Sounds like a moderation problem, if you ask me.
I believe you're being moderated.
So my question is probably not the best follow-up. We all have battles with C++. We all have battles with code. Is there any battle that's memorable to you that was maybe easy but took you forever to overcome that might stick out in your mind?
Is it working? Okay. Well, 20 years ago, people didn't really care about physical design, and they would write some really horrific balls of mud that were 10 million lines long, and it was incomprehensible. And that has been a battle for a very long time, and it still exists in many companies. And even after the book was out and they should have known better, it still happens. So it is an ongoing battle, and it applies to languages other than C++. It applies to any language with separate translation units. So I guess that would be my lifelong first battle, is to get people to think about, it's not an implementation detail. When you go to link your program, it takes, 2 hours or 3 hours or 10 hours or whatever. If you go to compile it, it takes a week. And literally that was the case when I was writing the book, because we had Mentor Graphics and they had huge programs and they none of the physical design considerations were considered at the time. It's really not their fault. And they had these Apollo computers and all of this stuff, and they would turn on their entire network, and then they would go take a vacation because it wasn't something they could just go to coffee over. It was days. So anyway, that would be my war story.
Okay, we could get one more war story.
I have the opposite of a war story. Sometimes things are fun. When we were working on the Ebook, we would try stuff and try it lots of different ways, and sometimes things were counterintuitive. And there were times when I thought, I must be stupid, I mustn't understand this. And then I would say to the team, I'm sorry, I'm so stupid, I don't understand this because when I wrote it, it did this. And they'd go like, just a minute. And then like 2 days later, they'd be like, you might want to try this build now. So that's the closest they ever got to telling me that I wasn't actually stupid. So I was happy about that. And that those things also sometimes happen when you're doing stuff that's still in alpha or less than alpha when you're writing about it.
So sometime ago, PHP was mentioned. So I was curious. Yes. So I was. It's not about PHP. It's whether any of you learned a new programming language recently and found it enjoyable. For some definition of recently, it could go from 1 year to like 10 years.
So, other than my adventures in PHP, I have actually programmed PHP. My blog is in WordPress, and I have to use PHP to do anything to it. I've also learned F#, which was my first introduction to functional programming, which was pretty challenging. For my day job, actually, I write C#. I'm not a professional C++ programmer. Occasionally, they make me dabble in JavaScript, which is good training for PHP, I guess.
Sometimes C++11 feels like a new language.
Whenever you use it well, it does feel like a new language.
Sometimes I use it well.
So I presume at these things you guys occasionally get together and go to dinner or whatever. I'm just curious what you guys talk about.
Hold on. This is the
quality of the beer.
Hold on.
Sorry.
But Bjarne, no. You may be confused. This is the Meet the Authors panel, not the Secret Cabal panel. And I can't tell you when that panel is.
Let's see, I seem to recall, because we had dinner, it was on Saturday night, you and Bjarne and I and another person, and we talked in particular about parameter passing. And I just came back from a dinner an hour ago with Scott and Stefan Lauve, and we argued about parameter passing. So those are two recent examples.
That just proves that Herb's interested in parameter passing. Just going back to the previous question, and still answering this question.
It was the one that was.
We're the one with the 5.
Jens Kahn's reference, by the way.
On strings. That's it.
By only standard strings.
That's all right. He's wrong, but we can have this discussion later. Let me finish here. And going back to John's comment about things he's been struggling with over the years. Something that we sometimes talk about is I absolutely detest the visitor pattern. And I think it's one of the most horrible workarounds that there exist. But it's a hard problem to solve. You can go for multi-methods if they're open. You can do open pattern matching. There's a lot of work to be done there. And sort of the deeper part of the answer is sometimes we do actually think about what might happen in 5 or 10 years as opposed to how do we use what we built last year or what can we build next year. That there actually is a slightly larger event horizon. I first wrote on this problem in the early 90s. I hate the visitor pattern.
So, I work in C++ every day in my day job. I do not have any insight into how standards come about. And Scott, during your talk, you mentioned something, I don't know, NCC 1701. No, that's Star Trek. Yeah, Star Trek Enterprise numbers. Yeah. How does that work? Can you guys give insight into how the standards? I mean, I presume everybody can be part of the standards body in some way. But how does it work? Can you give insight into how that happens, how it happens with you in your day jobs, how it happens in general, and maybe anything interesting that comes from that?
If I could interject one moderation point, this might be a better question for a certain other panel that we have this week, which is Grill the Committee.
Oh, okay.
Wednesday night.
Wednesday. Okay.
But if you guys want to opine, I could never stop you.
I will do a very brief answer. All the documents on the web, that's where Scott finds them. But to really take part and make contributions, you have to be there, you have to talk to people, you have to write proposals, you have to understand the context of the discussions and the proposals. And you have to realize that this is a process with 100 people present and maybe 300 people involved. It's not an easy thing to understand, and as every large process, it sometimes behaves weirdly.
I just want to remark as somebody who's not on the committee, sort of how things work from my perspective, and Bjarne's right, I do get the documents off of the web. I will remark that if you sort of want to get an understanding of how the committee works, the most obvious way to do it is to talk to members of the committee. So Wednesday night's panel would be a great place to do that. What's very interesting is if you start reading the standardization documents, and it takes a while before you can begin to make sense of them. There's some really interesting information in there. For example, you might see there was some proposal, and I can't remember what it was. It was the simplest possible thing. And there was proposal, and then there was proposal version 2, and then there was proposal version 3, and then there was it was 5 different versions for this really very simple thing. And as you read through those, you begin to find out, well, we changed this because of this comment, we changed this because of this comment, and it gives you really some insight into the dynamics of the kinds of things that the Standardization Committee cares about, and the way that they go about resolving certain kinds of issues. So when you ask, how does the committee work? I think it's worthwhile to ask the committee, what is their perspective on how things work from the internal view? But you can also actually get some really interesting insights about the overall process by reading through the documents. And occasionally, they're all human beings on the committee. They usually have their email addresses on the proposals, so I am not shy about sending the mail and saying, I read document 3922, what the hell were you thinking? In somewhat more polite terms. And they're usually very happy to say, look, this is why I proposed what I proposed. This is the other considerations. And you can learn a lot that way.
What's very often missing in the documents is the use cases that drives the change from one version to another. There is, in my opinion, far too little follow-up on the initial explanation of the problem to the greater set of use cases that drives future versions.
Thank you.
So earlier you touched upon publishing. I mostly read ebooks nowadays. And you talked a bit about it, but will you focus more on making not PDFs, but real ebook content easier for us to read? Because programming books really don't do well as mobile right now.
Can I ask you what aspects of ebooks you don't currently like?
Indentation.
Okay, formatting?
Yeah, mostly formatting.
Okay, code formatting or the rest of the book formatting?
Mostly code formatting, but some like chapter layout probably works better on printed books. So that's why I usually stick with PDFs instead.
My perspective on the issue is that from working with Addison Wesley, who I worked with for many years and continue to work with to some degree, and O'Reilly, which is who I'm publishing with now, my perspective is that in the past, authors have always assumed we will write a book, it will be published as little pieces of black ink on a white piece of paper, we will know how big it's going to be. And the publishers have assumed the same kind of thing. And then in recent years they went, oh, and there's also this whole digital thing. And the mindset was very much, we're publishing a printed book, and we were also going to have to convey it in digital form. But there was never the intention among everyone involved that it needs to be produced well in digital form. So all I can tell you is that I spent a lot of time trying to think of what I as an author could do so that I would deliver something to the publisher that would look good on paper, in black and white or color, would look good on mobile devices of a reasonable size, and I'll define that in a moment, in color or in black and white, in portrait mode or in landscape mode. And the definition of reasonable size is I can put at least 64 characters on a horizontal line without a line break being introduced. That's the definition I chose to use. So I think that publishers are beginning to recognize that digital is increasingly important, and I would hope that as we go forward, authors will do a better job of preparing manuscripts that will look good in that format, and publishers will do a better job of translating those manuscripts into that format. I currently do not know what my book is going to look like on digital platforms. I hope to find out later this month, and I've told them from the beginning what I'm hoping for, and we'll see whether it turns out to be that way. But I know that all the publishers are interested in that, but it takes a long time for the publishing industry to turn around and recognize that this is not a print first, and digital publication second kind of operation.
I haven't thought anywhere near as much as Scott about this, but I'm actually very touchy about how my code looks. And I would not program on a cell phone or an iPad. And the reason is that there's just not enough horizontal space for the code that I want to write and the code that I want to read. I do not like the Pobble double column format for code. And I don't see a solution for what people want as handheld gadgets that they can take in the bath or not. And the code, I can handle the text, but the code itself, I really want a larger screen. So my books don't look all that great on an ebook unless you bring it up on a proper screen and a proper computer. And I have no solution to that. But I really think when you're writing about a programming language, you're writing about code, and you should write code that is at least approximately what you would like programmers to work with. And I don't want the code warped.
Chandler, why was I smiling at you?
Are you going to throw me under the bus here?
Yeah.
So, Scott and I had this...
Wait, I'm not throwing you under the bus. You're driving the bus. This is a really cool bus.
I know.
You have to get out, get in front of the wheels.
Yeah. So Scott and I actually had a conversation at Going Native about this exact issue, because I just presented an automatic code formatting tool. And my shameless plug, since you made me talk at all, is if you've never heard of Clang Format, go find it, use it once, and you will never go back. Okay? It is the most silly and yet revolutionary thing I have ever done to writing code, because I stopped worrying about how my code was formatted. Now, that's my plug. So the thing that Scott mentioned was, wouldn't it be nice if the Kindle or the iPhone or whatever the device was, when it was rendering your ebook, would just have a rule set that you controlled inside the ebook that would pick a set of formatting rules and just reformat your code to however many columns were available. And I think this is, if not ideal, possible. And I tried to convince two folks from Amazon to actually do this on the Kindle, and I didn't succeed yet. But if you know anyone who could help me succeed.
The really cool thing about this is it means that you could take even a device, I'm still going to say of reasonable size.
Of course.
You take a device of reasonable size and you can decide, do you want to look at it in portrait? Do you want to look at it in landscape? And then if you want to, you can increase the font size to something which is comfortable for you. And if it turns out that the lines are too long, they will automatically rewrap in a way that the author of the text would have approved of. And Chandler gave a demo last year, which they had to clean up the drool under the floor from where I'd been sitting. It was so sad. It's the perfect solution to the problem if it can be made to work, on a widespread basis. So that's really my stopgap was to say I'm going to assume I have 64 columns, but the proper solution is I should be able to write the code as an author the way that I want it to be seen, and then put in some rules saying these are how things that should be reformatted. We have computers. They have lots of computing power. They should dynamically reformat the code on the fly. That's what I think the answer should be.
And if anyone here can make this happen, please talk to me and I will put you in touch with the right people.
Thank you.
So I saw Herb's talk today where it was all about lock-free linked lists, and then I saw Chandler's talk today which was all about how we shouldn't use linked lists. So my question is, are linked lists an exception when you're doing lock-free programming, or would a construct like a synchronized lock-free vector, for example, be something that is useful?
So I need to defend myself because in my talk today, I very carefully, including in the part where I said not just have linked list nodes, but not have the T object in the node, do a separate allocation and to have it not be in the node, have a T star in the node. On the slide I had, wait, what? Somebody said, what? And I said, normally you would not do this. You're signing up for more allocations. It's because you're making other threads faster. It's because you're reducing contention. So you're doing it for a very good reason. That is not at all the same thing. And I think the part of your talk that I got, you said something.
I'm not on the panel, man.
You said something very similar to what I said in my April talk, which is on Channel 9, about modern C++ and using it, and that talked in part about the importance of memory ordering. And that is important. And in fact, it was so important that we arranged for a keynote on that topic on Thursday. So be there. That is important. But again, sometimes an indirection really is a solution to the problem. You just don't reach for it blindly without considering the costs, because there are costs and there are benefits to being contiguous. You only reach for that, not as a premature optimization, that's a theme this week, but as an optimization when you know what you're getting exceeds the cost, and you're doing it for the right reasons. Measure, measure, and then measure.
I'm sorry, I have to. How many times do you write a lock-free linked list?
I have never written one.
Good. My advice holds.
Thank you.
Two comments. If you want a lock-free vector, I wrote one with one of my students. You can find it in my publication list and get a copy if you like. Secondly, I'm reminded of my old advisor, David Wheeler, who formulated what has been known as the first law of computer science, that says every problem in computer science is solved by another indirection, except, of course, for the problem of too many indirections. You have to remember the second part.
There is lots of information on the internet about like not only lock-free code, but like one level below memory models, sequential consistency barriers and stuff. The problem is part of this information is obsolete, part of it is contradicting each other. So any plans to cover these in some like definitive guide book, like C++11 memory model? Probably the make the atomic weapons, but in writing.
So that atomic weapons talk that's on Channel 9, 3 hours long, is all about that, and I made sure that talk was recorded so I would never have to give it again. As far as I know, with the exception I've got one bug report on one slide, that is, I believe, still correct as explained and goes way deeper than you probably need to know, but is trying to be complete, at least for the C++11 memory model, which is extremely similar to the Java and other modern memory models because software has coalesced around sequential consistency for data race free as the memory model. Now the hardware is catching up, which I also mentioned in that talk, which covers ARM v8.
Yeah, the talk is fantastic. Any plans to like make an add it into a book, or?
Search the slides. I have no current plans to write more about it.
So probably one of the first book that was written on this subject, pre-standardization, was Anthony Williams' book on C++ concurrency. Much of it still remains valid despite what's happening in the committee. But ultimately, I think we really want to ask, I think some of the advice that we're trying to give is, why do you need to note it down to that level of detail? One of the things that we've been trying to do is keep it up at a certain level so that it's useful rather than reaching that low of a level. But if you do want to find out about that, I think Anthony Williams' book is very good on that.
Thank you.
I don't know, I think this is going to rehash a little bit of what he was asking about, but there's been a lot of comments about how the compiler will rearrange lines of code, how underneath the hardware will also do things to your lines of code. And when I'm sitting there and I'm looking at the logic of the code, I sort of have a feel as to what it's going to do, but I feel like as the optimizations and other things are happening in the compiler and the hardware, it's becoming harder and harder to figure out exactly what your code is going to do. And I'm wondering if there's going to be any attempt to sort of unify the hardware aspects of optimization and compiler aspects of optimization along with the software, so that we're looking again at a single set of being able to look at code and say, all right, I know that this is going to, at this point, move out of the L1 cache into the L2 cache because of this operation. And I just don't feel like that information is really there.
L1, L2, L3 doesn't exist in the memory model. If you want to know that, you have to know your hardware. You have to go and relearn it again when you go to a different machine. When the next processor in your series comes out, you'll have to learn it again. It is really below the level of the language. The memory model that we give you is something that says, most of the time it works exactly as you naively expect, but for performance details, if you really want to know about that, you have to know about your underlying machine.
There's really two parts to it. One is levels of cache. There's no standard way of knowing it. You must know your hardware. But the part that's actually in the standard, the instruction reordering and stuff, the defaults are great. Remember, sequential consistency for data race free. That means sequentially consistent. Your code does what it says. It follows the language rules. There's nothing to know, as long as you don't write a race condition. If you write a race condition, you can see hallucinogenic results. The same as debugging an optimized build, and it is exactly the same problem for the same reason, because a debugger gives you a view into optimized code that is like another thread that's not obeying the memory model. So actually, those two are direct comparisons. So if you don't write a race, your code will do what it says, and you can actually read it and understand it, and that's a wonderful feature. The separate problem of debugging optimized builds is not what you asked about, but since we mentioned it, is also getting better, including in our product. Finally, we're doing some work on better debugging for optimized builds, and so tools are getting better for that too. But in terms of your code meaning what you think it says, I don't think that's gotten any harder in terms of instruction reordering, as long as you don't write a race condition. Although yes, the memory hierarchy continues to get deeper, and we need to know about it and deal with it, and there's not currently a standard way to do that.
So even on PowerPC, where I live, and it lives on a very weak memory model, I still follow that advice. Rarely do I really need to go down to that level. I do know how to go down to that level, and I've given many talks on that, but for the most part, I don't really see programmers needing to go to that level. So it's certainly a great research topic, and research loved it because they said, well, you know what? Why do you not study the x86 model? It's too simple. There's not enough curiosity in there. This is why they hit us so hard, because, oh, it's wonderful. It's great for research. That's their level.
So, I mean, what's been said is right. If you're doing that, you're really starting to tie yourself to one piece of hardware, one processor architecture, right? You know, I've written code that goes down to the level of understanding how big the cache line is and taking advantage of that. But it's not very portable. Actually, you're far better off if you're concerned about that sort of thing and still want to maintain some level of sanity. Look at things like cache oblivious algorithms, where you're trying to essentially leverage the cache in a sensible way without really knowing a lot about it, for instance. If you want to go program your cache directly, go start playing around with GPUs. You can have all the fun of being your own cache controller.
Doctor, it hurts when I'm thinking about relaxed memory models.
Don't think about it.
So I just want to point out we are technically past 10 o'clock, and so I don't know that we can hold captive our panel any longer. I'm happy to stay here as long as they are happy to stay here, but I feel obliged to let you people free if you need to be.
We thank you for staying.
But we may be at the end of the questions. Well, if that's all the questions, I'd like to thank our panel for doing a fantastic job of answering all of the questions.